Warm greetings to everyone present here in Expert Talk. On behalf of Gromer Faculty of Engineering, Diploma Engineering College, Himmatnagar, I, Professor desiccant in Mechanical Department, welcomes you all for this expert talk on desiccant assisted dehumidification and cooling system. A man with great vision in innovation and icon for hard work, Dr. D.B. Chani sir. He is our expert, presently Associate Professor in Mechanical Department, Government Engineering College, Dahod, which is affiliated to Gujarat Technological University. In his introduction, Sir is a PhD scholar in thermal science from Indian Institute of Technology, Roorkee. Currently, PhD supervisor at Gujarat Technological University. He published more than 134 research articles in international conferences and journals, including for reputed books. His area of research is desiccant cooling transit exergy. I welcome you, sir. I respectfully welcome our principal, Professor Bharat Sudhar, Gromer Faculty of Engineering and Diploma Engineering, Himmatnagar, who has been the pillar behind this event. I welcome you, sir. I extend to my welcome to all HOD different departments and faculty members and participants who are gathered here in this webinar to radiance this occasion. Thank you all.
College Dahod, I will have also served to the reputed institutes like Faculty of MS University Baroda, Government Engineering College Modasa, LD College of Engineering Ahmedabad. There are so many number of publications credited to my work in the different reputed international group of journals. I am also working as renowned reviewer in the different publication group and reviewed more than 300 research articles in the peer-reviewed journals. I am also working as editorial board member in the international journal group. I have also written one popular book related to solar air conditioning, published by Springer Publications. I am participated into the 24th International Congress of Refrigeration held at Yokohama, Japan. I am also working as editorial team member of the reputed international as well as national of conferences. Also, like to have been working as a speaker upon the invitation to the reputed institutes of Gujarat as well as the India. There are so many number of Google Scholar citations credited to my published articles. Also, a lifelong learner in access to taking the lecture, also learning the same for to enhance my knowledge. So first of all, before knowing, studying, or to deliberating to the desiccant cooling, one of the questions will have definitely born into the mind of everyone, that what is the future of this research area? Because whenever you opt your research into this field of cooling, air conditioning, HVAC technology, you must have a certain good progress in the coming days. There is a need of thermal comfort because men can work efficiently within some range of temperature as well as humidity that can be defined by RSRI group, American Society for Heating, Ventilating and Refrigeration and Engineers. All air conditioning engineers coupled together in America from all over the world, and that can make the rules regarding need and requirement of the thermal comfort. So thermal comfort is the state of mind that expresses satisfaction with the thermal environment. So for to increase the human efficiency, thermal environment will be must. If suppose consider the situation in which you might have to work into the temperature about 50 degrees, so your efficiency is not good as you work it to the low temperature 25, because our body temperature is around 36 degree centigrade temperature. So temperature lower than that can make us to work efficiently by rejecting the excess heat to the surrounding cooled atmosphere. The concept of thermal comfort will have get determined by studying the so many parameters such as like materiological, psychological, sociological, clothing, and it depends upon the conditions of the local environment, so that the concept of this thermal comfort is not easily quantifiable. So ASHRAE, American Society for Heating, Refrigerating and Air Conditioning Engineers, defined certain rules and regulations regarding to the availability of ventilated air. Ventilated air is the fresh air that will consist of required quantity of oxygen to make the hygienic
Sir, sorry.
conditions of
Hello.
the indoor. Yes, yes, sir.
Sir,
So ASHRAE given out certain standard for to provide ventilated airflow, fresh airflow. So the standard 62 to be resumed in the year 1981 as listed for the various applications like hotel room, auditorium, meeting room or office. So you may have seen that for office room, it is simply a requirement of 2.5 liter per second air per person. Okay. So same can be ameliorated in year 2001 regarding to the 10 liter per second per person. That increase was around 400%. So that day by day, as outdoor ambient will get spoiled out due to the detrimental effects of global warming as well as the pollution, that requirement may also be get tightened more by the day by day incorporation in the different ASHRAE standard. So first and foremost method for cooling the air, or you can say providing the thermal comfort, is the evaporating cooling. Thermodynamically, we can say evaporation is the endothermic process, so that heat is getting absorbed by the molecules of water particles getting evaporated. So in evaporative cooling, we have to flow the water in a TD particle forms against the flow of air, so that that air is as below its temperature unsaturated conditions get evaporating the molecules of droplets of water particles, and so that it absorbs the heat from the air, and at the other side air will provide it to be a cooled condition. So there are certain limitations for the evaporative cooling. Evaporative cooling will be performed better whenever air is unsaturated. But the deep cooling summer months, such as like June, July, August, whenever air is to be saturated, its relative humidity is to be increased almost about, you can say 17 to 80%. So whatever may be capability of air to evaporate the water can get retarded, so that effectiveness of evaporative cooler gets reduces. So that the best month for to get evaporative cooling comfort is the April and mid of May. Then after evaporative coolers, air become inefficient due to its climatic applications. Okay. So far, another invention in this field of thermal comfort cooling is a vapor compression based air conditioning. In vapor compression based air conditioning, one evaporative cooling coil is to be provided through which a refrigerant gets evaporated. As I tell earlier, refrigerants are the group of chemicals having its low boiling point. So below atmospheric temperature, refrigerant gets expanded into evaporator coil. So during expansion, it abstracts the heat from its surrounding over to the coil, where air strikes over to the surface of the finite coil. So air loses its temperature, and the same heat is provided in form of latent heat of vaporization to the refrigerant to convert it low pressure vapor. Then the same refrigerant getting compressed to condense it to the higher temperature with the available outdoor air. And the same can get reduce its pressure, so that can possibly boiled to the lower temperature with the help of expansion device. So that is simple construction of conventional AC work. In conventional AC, we have a single coil for cooling and humidifying the air. in the earlier definition, we may see that air conditioning is defined as the process for simultaneous control of temperature, humidity, and moisture. Common laymen have their idea is air conditioning means cooling, but in what terms it cooling? It not only control the temperature to be controlled according to the standard provided by SRA, as we see earlier, around 25 degree, and the relative humidity should maintain 50. That temperature never been constant for the atmosphere, that humidity is never been constant for the atmosphere. You will have to make it controlled by providing any kind of HVAC device with the indoor thermal comfort provision. So to control the humidity, whatever may be the moisture present in the air should be removed, and the method provided here in conventional AC is condensation of moisture. Moisture can condense at some particular fixed temperature, equal the dew point temperature. So cooling coil temperature maintained to be very low, below the dew point, so that the moisture, excess moisture in case of high humid air should be condensed and removed out. Okay, so dry air then after available in cooled form will provided the room for further cooling. But for the process of maintaining very low dew point, around 2 to 3 degree, 5 degree centigrade temperature, you might have to cool the refrigerant at very low temperature, and that's why sometimes air available from the evaporator cooling coil will get overcooled. As it gets overcooled, you might have to reheat it again to meet the supply design conditions, which is to be available temperature 17 to 60 degrees centigrade. So there are certain limitations of the traditional vapor compression. Traditional vapor compression consumes lot of energy by use of compressor, and that compressor has to work in excess for to remove the humidity in a process to maintain its dew point below atmospheric one, and that overcooled air will reheat again to meet the supply conditions and such a way that it decreases the COP of system. Another one, your evaporative cooler requires only fan or some small pump to circulate water, but it does not control the humidity. So only cooling functions can be carried out with the evaporative cooler. That is sufficient when unsaturated air is there, ambient humidity is low, but when ambient humidity is high, air becomes saturated. Your evaporative cooler have drastically reduced its effectiveness. So both a system of controlling the temperature and humidity does not work with sustainable makes use of the energy. So this is the process on psychrometric chart. How can we reduce temperature and humidity of the supply air in the vapor compression system? So as you see here, some blue line. That blue line will show you first from right to left, means that to reduce the dribble temperature of the supply air. Then at saturated conditions decreases the humidity ratio by some value, means that dehumidification of water particles available in moisture parts. And then overcooled air gets reheated to meet the supply conditions by partly rising its dribble temperature, not as to initial, but partly rise. So there are so many methods available for to control the humidity. First, by heating. If you heating the air at a constant pressure, it decreases relative humidity. If you cooling the air below the dew point temperature, then the moisture portion available with the air can get condensed and be removed out. So that condensation process readily explained over to the surface. When surface temperature drops down below the dew point, moisture separates out in form of water droplets, can be collected and drained through a pipe. If its temperature, surface temperature, cooling coil surface temperature below the ice formation point temperature, then instead of having droplets of water, icy formation water can be available from the moist air in form of humidified operation. Another one is chill water system. In multi-story building, you can say multi-story hotels where you can say 200, 300 rooms are there for the purpose of cooling and condensing. So at that time, to provide refrigerant flow to each and every row over to the distance, you can say 100 meters or more than that is not economical. In that case, you may have to provide central chilling plant for cooling the water around temperature, you can say 2 to 3 degrees, just above its ice formation. And then that chilled water with the help of pump can circulate to each and every unit, and we can pass room air over to that chilling coil, and so that temperature and humidity can efficiently get controlled with that flow of chilled water circulating to the multiple room. That system is called chill water system. And in that system, we may have removed temperature and humidity by the separable temperature and humidity control. Number of books are available for to study the topic in detail. Sometimes solar energy, or you can say some form of renewable energy, may have been incorporated with the different system, such as called absorption, adsorption, desiccant, and ejector. So by comparison, you may have find here requirement for regeneration temperature in case of desiccant cooling is 440 to 100, and its COP will be in the range 0.5 to 1.5. That is comparable with all other systems, so that desiccant cooling systems can be opted to have been coupled with the renewable solar energy. So why we may change our conventional HVAC to be obtained either with the evaporative cooler or with the help of you can say conventional vapor compression cycle. Cost of handling the humidity is very high, because as you see that in vapor compression, you must have dropped down the temperature of evaporating refrigerant to meet the dew point requirement to remove the moisture condensation. Buildings were uncomfortable if you cannot control humidity above 60%. Buildings with a high latent heat load capacity is also been costlier in case of conventional system. Ventilation airflow is needed, but it is a UV, so that it costs more for controlling the temperature. Cold building costs more than the comfortable one. If you cold building excessive, then it is just a wastage of energy, not other than that. Okay. Most of time we are using a split AC for our home, but anyone does not know about the one of the great disadvantage limitations of this split AC. It does not provide you any percent of fresh ventilated air. It just cool room air again and again as per the requirement. Two units are there, outdoor unit and indoor unit. What the units are coupled each other through the two pipes. One is pipe conveying compressor and evaporator, other pipe connecting compressor with the condenser. Condenser. So in both the way, only refrigerant itself travel from in to out. No more air is to be required. So far, while you are using a split AC, it is advisable that partially around 5% opening of your door or windows, that certain air exchange can meet you the requirement of fresh air. Or either open your door partially, door opening time 1 to 3 times during the hour, so that much meter cube of air is to be swept and you might get available fresh air. Otherwise, what happens? Sometimes if you working split AC and remain closed it for 10 hours, then it's serious for to make a hygienic conditions by decreasing the proportion of oxygen drastically to a very low value. So which are the problems we can face with the use of conventional current HVAC? It is too costly for to consume the energy. Around 40% of total building energy uses for thermal comfort cooling. This technology cannot control the humidity effectively and economically. Why not effectively? Because if air cooler is used with the saturated air, more humidity, most environment decreases its effectiveness, very low value. And economically, in VCR, if you go for controlling moisture, you must have to decrease the temperature of evaporator to a very low value. so that the compression work can be increasing. Health and comfort suffer because of limited fresh air or ventilated air has been supplied. Existing system deteriorate and maintenance cost is more because it has to operate very high pressure and temperature range. Very high temperature, you can say, at exit of compressor, and very low temperature at entry of evaporator. First cost of good system is high. It is costlier than two. Okay, and making up some space for its installation. Its ventilation load pickup time cannot met, and so far IAQ, indoor air quality, suffers a lot. Existing system do not clean the air but circulate contamination. In case of air conditioning, to have, you must have three things to occur simultaneously: cooling, dehumidification, and cleaning. But filters are provided. That filter floats out on its prolonged application, and such as whatever may be contamination can get circulated, recirculated in room again and again. So that in corona pandemic, as it circulate room or in any closed space, it is not advisable to have start with central AC plant in most of the big bazaar or some kind of mall when you go for the purchase, because each does not clean the contaminant but circulate it out again and again upon cooling and controlling the air. Overcooling and reheating make the unsustainable use of energy. Once you cool excessively to control the temperature and humidity bath with a single coil, and then after you may reheat again to meet the supply conditions, will not make the sustainable use of energy. So for better thermal comfort, temperature should be in range 25 degree and humidity should be in range 50 degrees. So one question born in almost way in the mind of the people like you, that why humidity should be in a peculiar range of, you can say, 50% only. So in the coming slide, now we may have to see here, whatever may be the abscissa horizontal axis show you the increase of humidity starts from 0 to 100%. An ordinate vertical y-axis will show you about the different infectories like bacteria, viruses, fungi. So as there are certain pink light and contrast area, and some yellow area can be marked where this pink regions will have a dimmed color. So that will be in the range 40 to 50% humidity. At the start, when relative humidity is very low, you find that infectants to grow in a very high rate. At the end, when humidity is again high, at that time that contrast is more for the pink color, so that infectants will be dominant in this infection. And at central part, where this pink color will be you can say in a very light way, so that you find in this narrow range the infectants susceptibility will be minimum. But so this graphs can also be explained with this RH range also. You might see certain dominant area, central humidity range of 40 to 60%. That peak areas will be minimum of narrower band, so that within that area dominance of infectant circulation will be minimum. So that in that corona pandemic, maintenance of humidity by this HVAC is almost important, that it should kept around in range 50%. So that is the main reason why we have kept 50% humidity along with 25 degree centigrade temperature. Dehumidification, almost we are using vapor compression kinds of cooling technique in the olden day. That technique is to be known as a direct expansion system. So its construction, it basically consists of four components called evaporator, compressor, condenser, and expansion valve. Yes, it is a topic of due study in diploma or graduate level, so I may not go much detail into the same. Day by day, as from the graph, you may see amelioration and growth will be there in the purchase of air conditioning and HVAC equipments increasing decade to decade. That is why, yes, sir. Any interruption, sir?
No,
Or my
continue, sir,
voice?
please.
Okay, okay. So that due to deteriorating into the quality of air, or I mean in terms that the temperature may go beyond rising due to global warming and other effect, will great consumption in the electricity as well as the purchase of HVAC will demand a system that make use of a low electrical energy as far as make sustainable use of the same. So how the desiccant cooling that differs from the conventional cooling system? First, here the diagram, as my arrow shown you, with the working of conventional cooling. In conventional cooling, single cooling coil, evaporator cooling coil is provided that will have to make the function of cooling and dehumidification work with a single coil. How will do dehumidification? As I explained earlier, by maintaining the surface coil temperature below the dew point, and it gets cool the air parallel to, so that when air available at a temperature state point 2 will be overcooled, because you might have to reduce the temperature of refrigerant very low so far as moisture in form of condensation to be removed to make air dry or dehumidified or to control the humidity. But it gets overcooled to meet its supply condition, which is temperature around 16 to 17 degree. It gets reheated by passing it through the reheater coil and then supply again to the room. So here single coil will have to perform the duty of cooling and dehumidification. So suppose your air is dehumidified already at a state point 1, but you might have to run your coil in parallel with what predetermined temperature and relative humidity criteria, because it can occur simultaneously with the single coil. So the same can represent as a process in a psychrometric chart, as a state point 1 to 2 is cooling and dehumidification, and 2 to 3 is reversibly reheating to make over to the overcooling. Now this is how our lay system, current system, has worked nowadays with our split AC and all other conditions. Our innovative system is called the desiccant assisted dehumidification system. Here, the operation of dehumidification and cooling can be split into the two components. The dehumidifier provided initially to control the humidity of the air, and rest cooling can be done by providing either a VCR or either a air cooler coil. Okay. So what is difference here? The function of cooling coil in desiccant and cooling coil in conventional vapor compression. In cooling coil of desiccant, it has to control only the temperature. So there is no need to drop down the temperature of the working surface coil to 2 degree, 5 degree, likewise to remove the moisture. But it has to be set at a temperature, you can say around 15 to 17 degrees centigrade. So almost you can say 15, 17 degree rise in the temperature of refrigerant to be maintained to the cooling coil is achieved. And another thing, that amount of electrical energy may be saved. Suppose you may require here 2 TR AC, here just 5.5 TR AC can do the same function of what it to be done at a conventional cooling coil here. And another, if your room temperature is achievable in terms of temperature, this cooling coil is made to put off its operation so that the energy can be saved. Here not, because cooling and dehumidification parallelly, simultaneously done. So you cannot putting off your coil, but it has to run its predetermined temperature range. Another one, circulatory rotary wheel is provided. That wheel is known as dehumidifier. You have to pass moist air through the dehumidifier, and after passing through dehumidifier, that air gets dehumidified, dried, so that almost humidity is to be removed by the operational state point 1 to 2 that has been shown here on a psychrometric chart as a difference of state point 1 and 2. Rest cooling is only be done at a cooling coil. So how dehumidifier will remove the moisture? Dehumidifier contains some chemical known as a desiccant materials. You have using some desiccant material in your home too. Many people hearing first time this word about the desiccant. Desiccant is nothing but any chemical, any substance having affinity with the water is called the desiccant. You have ordinary salt in your kitchen, that is a desiccant. What will be the condition of salt in a monsoon? Monsoon ambient humidity is 100%. At that time, moisture get retained by the salt, and salt at that time converted into paste, not in the powdered form. What we observed in these days, in summer or winter. Another one, wood. Wood is a good natural desiccant. If you have your house have a wooden doors and windows, then you find difficulty in closing it out during the
Sir,
period of a monsoon, because in monsoon ambient
sir,
humidity or yes sir, that desiccant are the materials which get absorb the moisture. So physically, how it is possible? Uh, as moisture is there in the air, and you might have certain oxygen, nitrogen, carbon dioxide, helium. Similar, some moisture presented always in terms of you can say water vapor, and that proportion is higher is said to be humid air. When its proportion is lower, it's said to be a unsaturated air. Okay. So whenever air saturation occurs, relative humidity occurs, we find greater perspiration. This is because that air will not store more moisture, and so it is difficulty for our body to exert out more heat to the surrounding atmosphere. So Dalton law will have tell its statement into the mixture of gases. Pressure exerted of individual gas pressure is equal to the total pressure. So suppose when humidity is higher, it's a molecule exert greater pressure, and that lead to balance the total pressure. So desiccant material having the affinity with the water, and it can have a dry surface, mostly having very low surface pressure. For the material to be desiccant, it is required that under dry condition, its surface vapor pressure should be low. And what happened to the moist air? Its vapor pressure will become higher with having higher proportion of moisture in air, so that having the high pressure, and desiccant surface provided here in humidifier having low pressure. So all you know that the moisture then will travel from high vapor pressure to low vapor pressure, so that it can get saturated over to the surface of desiccant layer provided over to the desiccant lily. And so far, by losing the moisture, air will become dry and cooled further in the cooling point. So now what happened to the desiccant wheel? Once air gets condensed over to the surface of the desiccant matrix material, it will become saturated, and then not in capacity to absorb more moisture, because once air gets condensed over to its surface, its vapor pressure gets increasing. So the difference of vapor pressure getting shortened as moisture getting over to the surface of desiccant. So you need to regenerate it out, dried out that moisture. So you reversibly flow as shown here as a regeneration air. You may have to pass air through the heater that will increase its temperature around 19 to 100 degrees centigrade, so that its vapor pressure is then very low under hot condition. Vapor pressure of air is different if it is available 25 degrees centigrade, and vapor pressure of air is lower if it available 100 degrees centigrade. So now reversibly in the dehumidifier reactivation section, opposite thing occur. Saturated desiccant having the higher surface vapor pressure, and hot reactivation air having lower pressure. So moisture remove the friendship of desiccant and travel along with the dry air provided to be from heater at a 100 degrees centigrade, and then that moisture exhausted to the atmosphere and will become a dehumidified, dried, and can get absorbed moisture again when a moist airflow made to pass to the process air section. This is simply how a dehumidifier works. However, desiccant cooling can get deviates in terms of it working from the normal conventional cooling. Here, we may have splitting up dehumidification and cooling operation not into a single coil but into two components. One is dehumidifier, only take care of the drying the air, and another one cooling coil which has to control only the moderate temperature for the cooling to meet the supply condition that is very high as compared to the normal cooling, which require the temperature to be maintained 2 to 3 degrees. Which are the benefits of the desiccant cooling system? It is environment friendliness. If and so it required that evaporative cooling is sufficient to meet the supply condition, then there is no at all need of the environmentally polluted refrigerants. It saves a significant potential of electrical energy by reducing drastically the size of conventional vapor compression system integrated with the desiccant dehumidification. It is got to be a viable and variety source of energy called solar thermal energy, waste heat, natural gas. As we see here, we are providing some kind of heater so as to provide the heating energy, diversified field source required, electrical energy, solar energy, waste heat available in the industry, CNG based, so as to minimize the cost of reactivating the dehumidifier. Indoor air quality is improved because desiccant cooling has to provide more flow of ventilated air as far as its cooling coil is concerned and temperature concerned, so that with a greater ventilation heat load to occur, it will give you better economy in cooling and you can say making the thermal comfort within the closed space. Operation of desiccant cooling is nearer to the atmospheric one, so that it required and neglects any maintenance which is to be occur either at very high pressure or low pressure, as we see in a conventional cooling. Desiccant systems can be used for any kinds of diversified ambient situation, either summer, either monsoon or winter, by changing the configuration of the system. In salient features of desiccant cooling, it can make the separate control over to temperature and humidity. If temperature control get achieved, close the cooling coil. If humidity control is achieved, close the dehumidifier. So in either way, either temperature coil or dehumidifier may have to work if the criteria is getting achieved by the required concern. Large ventilation airflow to provide fresh air, which makes higher indoor air quality or to get better hygienic conditions. Low grade solar or waste heat to be coupled for regeneration. It can also be integrated with the cogeneration system, where in industry you need a dual power and process heat requirement. It drastically reduces the size of cooling unit and operates at ambient pressure are the features. So desiccant cooling at a time can make the coupling of clean energy, clean technology and clean environment together. There are different types of desiccant cooling according to the material, according to the kinds of different desiccant used in making the system. That may be according to application and desiccant type. Desiccant cooling may be used in many parts of the world according to need and requirement. There are different materials to be used both as a solid desiccant and liquid desiccant. Two categories, solid desiccant and liquid desiccant. In solid desiccant, chemicals like silica gel, available mostly in globules from when you purchase any new mobile, laptop or some electronic device used for drying purpose, activated carbon, synthetic polymer, metal silicate, etc. In liquid desiccant, we might have to go through triethylene glycol, lithium chloride and calcium chloride. And according to solid and liquid desiccant, the respective system can be done as adsorption or either the absorption cooling system. Characteristics of the desiccant material. Material to have been opted as a desiccant material should have a low surface vapor pressure when it will be available in time available. So only the critical criteria. This is the internal view how the desiccant will or dehumidifier will look like. This is solid desiccant will. Its internal surface can be made with a matrix, and that matrix then get laden with desiccant material. This is the typical applications of desiccant cooling system: supermarket, theaters, hospitals, hotel, office building, indoor swimming pool, pharmaceutical plant, and library. Desiccant cooling primarily either go for cooling the large area or where high human occupancy to need to control the high latent heat load. This is the simulation performed for to explain you about the working of dehumidifier. First, as we see here in a green arrow, wet process air may have entered the wheel, and after dehumidification, dry process air may be taken out. On the reactivation process area side, reactivation air in plus to the heater, rising its temperature to around 100 degrees centigrade, and after flowing that hot air to the dehumidifier, get remove the moisture, and moisture can travel along with the open atmosphere as a exhaust air. So this is how a real dehumidifier looks like. Horizontally, it can be placed over to the cabinet compartment separated in process air and reactivation air section. Size of dehumidifier may be according to as high as what will be the height of human according to maintain the required airflow. This is the last slide today we are going to discuss. This is the coupling of solid desiccant dehumidification system with conventional VCR system. Through simulation, it is explained you about its working. Here, certain arrows showed you in a blue color that represent process air. Process air is the room moist air taken it for the purpose of conditioning. Between state point 1 to 2, that process air losing its moisture and becomes dry. Then it made to flow through the enthalpy wheel for partially cooling, and then for final cooling will send to the conventional VCR cooling coil. By maintaining its temperature to the supply conditions at a state point 4 will again return to the room as concerned. It is a conditioned air. And whatever may be the black color will show you the flow of refrigerant to the different components like evaporator, compressor, condenser, and expansion valve in the refrigeration cycle. And red color arrows in the simulation chart will have to show you about the regeneration air. Regeneration air may have initially taken from ambient so that that air partially gets heated to save the energy needed to be at the part of heater. After passing through heater, finally the temperature of this reactivation air to be achieved around desorbing temperature of the particular type of refrigerant used in the dehumidifier. Then after passing through the dehumidifier, it will dissolve the moisture, and so far as a exhaust air can expel to the atmosphere. So the wheel is ready in a unsaturated way to saturate more moisture in the next cycle to work it continuously into the circuit. This is all about the simple working principle of the desiccant cooling. Now I have opened up the platform for making discuss over to any questions you have, because we have the limited time today, as I am my lecture to be start to be at 10:30. So I invite any faculty, any student who wanted to have any question, any query regarding to the discussion. It's just a 2% part of my overall presentation. It can coupled this different aspect, starting explaining the system in detail. The second part will be in terms of how to get performance evolution by simulation, by experiment, how to predict further experimentation with some, you can say, artificial neural network technique to get energy modeling to the exergy analysis. So there are different parts and components, each by discussed in detail in future if anyone wanted to know that part for that portion. Thank you all for hearing me patiently over a time of around an hour. Thank you, friends.
Thank you very much, sir. I request to Rajnikant sir for vote of thanks. Kindly, sir.
Okay, sir.
Uh, Thank you, Maulik Nagarji, sir. Uh, it gives me immense pleasure to deliver a vote of thanks. First of all, I would like to thanks from my heart to respected expert Dr. D.B. Jani, sir, who blessed us with his presence and giving his valuable time. Thank you, sir.
Okay, thank you.
I also like to extend special thank to our principal, sir, Dr. B.D. Suthar, sir, for giving his support and cooperation. Also, thanks to mechanical department for organize this type of event. Last, I would like to thanks all participants who actively get knowledge from this event. Thank you all.
Okay, sir. Thank you. Now, may I close the session, sir, as I am continuing with the
Sir,
routine?